And tonight we celebrate the presentation of the university's Lewis Thomas Prize for Writing About Science to Dr. Ian Stewart and Dr. Stephen Strogatz. Thank you for being part of this special occasion. Now, before I introduce our honorees, I want to share a little bit about the history of the prize. The Rockefeller University established the Lewis Thomas Prize in 1993 in honor of its first recipient, writer, educator, and physician-scientist Lewis Thomas. The award honors, quote, the rare individuals who bridge the worlds of science and the humanities, whose voices and vision can tell us about science's aesthetic and philosophical dimensions, providing not merely new information, but cause for reflection, even revelation.
You two collaborated on in Scientific American coupled oscillators and biological synchronization, right? Mm. Which just knocked me out because it combined coupled oscillators like pendulums and heart cells that beat in synchrony with fireflies that flashed in synchrony, covered a whole range of things and explained them in story and vivid imagery, and I just loved it. Was there one particular moment where you realized that we were talking to somebody and realized they ought to know more or anything like that?
No,
What made you put pen to paper or finger to keyboard?
My father found an old typewriter in the basement of the bank that he worked for, and he brought it home. I was about 12 at the time. And if you've got a typewriter, you've got to do something with it. Yeah.
What made you know you wanted to write for the public?
Yeah, for me, I don't think of it in terms of writing as much as teaching. For me, the impetus was always to teach. And I remember they gave us some little quiz or questionnaire in junior high school, one of these things like to forecast what you might become someday, and my answer was teacher. I always felt like I wanted to be a teacher, and I don't really know where that came from, but I know that it was problematic because at that time, no one would listen to me. So that is, if I had, actually the first person who allowed me to be a teacher was a student in high school who wanted to learn chess, and I was a very avid chess player at that point, still play probably too much, as my wife would tell you, internet chess, but anyway, so there was a student who wanted to learn chess, and to me this was a great fantasy that I could shape the subject, show him the correct sequence of lessons to build up his chess strength, and this guy just wanted to listen, and that was exactly what I wanted, was to be able to have someone to teach. So, the idea that later on I could write, and as I say, I don't think of it as writing so much as conveying the beauty of this subject, the pleasure that it brings, the importance of it and all that. But it may sound wrong to say it this way, but I think Ian knows what I mean. That it's a little bit selfish, that we're not exactly doing it for the recipient. We're doing it for ourselves because it's so much fun to write and to explain and to teach.
When you communicate math, is it important when you make it clear to non-mathematicians something about your work, that it's not only useful to the lay people who'd be reading it, but possibly to scientists too who aren't in your field?
I wrote this book, it sold, various people bought it, and about 2 or 3 years later, I'm sitting in my office and I got a phone call. So I pick up the phone and chap on the other end says, my name's Len Reynolds. I'm an engineer at the Spring Research and Manufacturers Association in Sheffield.
Spring research.
Spring research.
You mean like in the bed springs?
Like bed springs. Yeah, that's right. And I think it's just solved a problem that we in the spring industry have been working on for the last 20 years.
What was the problem?
To decide to find a test for wire that would predict whether it will make good springs.
Oh. Some do and some don't.
Some do and some don't. And
something that never occurred to
I never thought about myself.
Can you tell which one is going to poke up through the mattress?
Well, nothing they could detect would tell them in advance whether the wire was good or bad.
How do you apply mathematics from chaos theory to that and solve the problem?
Okay. You need
Because I have a wire at home, I'm really worried.
a survey of their readers to find out what sort of things they really liked. And what they thought they were going to get was what they really liked were the things that were really useful, practical stuff, engineering, medicine, things like that. And what came back from the readers, who turned out to be people like lawyers and doctors and that sort of thing, was, no, what we want is to have our minds blown away by 11-dimensional space. And, but we want to be able to understand the first 2 pages of the article.
They expected to find that the most emailed science articles would be practical applications. And they found that there were articles instead about things that inspired a feeling of awe, which awe is, I would say, very similar to having your mind blown away.
Yes.
So if somebody gives you 32 dominoes and says cover the chessboard with them, you know how to do it. You can just 2, 4, 6, 8, 2, 4, 6, 8.
So with one
cover it.
part of the domino on each of the squares.
One part on each.
Adjacent
Yeah,
squares.
they have to. The dominoes have to just cover 2 adjacent squares. No overlaps, no gaps. Okay. Now suppose somebody comes along and cuts out 2 opposite corners, diagonally opposite. Now you've only got 62 squares, so 31 dominoes ought to be able to cover them. Now if you actually try this, it doesn't work. You can spend hours and you get almost all the way, and you've got 1 square over here and 1 square over there missing. And you can't fit a domino on unless you cheat, cut it in half. Okay? So why is that? And the piece of insight you need, there are 2 pieces of insight. One is every domino will consist of 1 black and 1 white square when you put it on the chessboard. It will cover 1 black and 1 white, because
Squares are always
squares,
right.
the next door square is the opposite colour. Okay, that's fact 1. Fact 2, diagonally opposite squares on a chessboard have the same colour. If I cut out 2 white squares, I've now got 32 black and 30 white. I can't cover them with dominoes that have equal numbers of black and white. End of story. And once you've seen that, you'll never forget it.
But notice the audience reaction to that. There were many people that it was the first time that you've heard this argument, and we could feel your pleasure up here.
I got it.
That is,
I'd say I had to lift my feet. It was oozing across the stage.
no, really. I mean, because you were just having a mathematical moment. So if you have not felt that before, that's what we live for.
Yeah,
I mean, that's what we're doing. We're trying to get that every day, and of course we don't.
Yeah.
We only rarely get it, but we're like addicts that we're looking for that over and over.
That's right. Now,
We don't know what to say. We just need great teachers and then leave them alone. But okay, that's the answer. Anyone have a better answer?
What are we?
no, I mean, yeah, I agree completely.
That's not a
with
real answer, though.
everything.
That's the problem.
There are a lot of unanswered questions, and you have to pick among them.
Okay, there's one called the PNP problem, and you can get $1 million if you solve this. And
Wait, let me get a
to-
pencil.
Okay.
P problems are something a computer can solve easily. NP problems are essentially ones where a computer can check an answer easily, but it can't find the answer easily. And the question is, are these actually different? If you've got a problem that if somebody comes up to you and says, I'll tell you what the answer is, as soon as they tell you, you say, okay, now that you've given me the answer, I can see that's right. But I couldn't have worked the answer out myself. So the problem is nothing, this is one of the great problems in theoretical computer science, and it's to show that these 2 things are different. So to put it simply, it's to prove that some problems really are hard.
It's like waiting for this beautiful ending to the story.
Like any good conversation, this makes me want to ask you 5 more questions, which we don't have time for, but the next time we talk, we will. And the best thing about it was that it was fun, and just the way math is. And thank you so much for being part of it.
Thank you.